So I think the biggest factors in our success to combat climate change and its impacts will be related to how quickly we can transform. I think it's also related to our ability to collaborate together as a global community. We really have to work on collaboration and inequality, and our biggest risk of failure, I think, will be not tackling and changing some of those deeper issues.
Hi, I'm Stephanie Tomampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. Today, we're taking a look at how remote sensing scientists are tackling climate change, and the approaches some scientists are taking are very different from what you'd think. This episode of Down to Earth comes from the Remote Environment Analysis and Climate Technologies, or REACT, Technical Committee of the Institute of Electrical and Electronics Engineers, Geoscience and Remote Sensing Society. The REACT Technical Committee fosters discussion between scientists, government, and industry to establish international standards for remote sensing products that address natural hazards, climate change, and the Sustainable Development Goals. To learn more about this technical committee and how you can get involved, visit their website at grss-ieee.org/technical committees.
I'm a geographer, which means that I do both social and natural science. And I'm a geographer that's been pretty obsessed with satellite data and what it can tell us about how the Earth is changing and how we as humans should be adapting to it.
This is Dr. Beth Tellman. She's a postdoctoral fellow at Columbia University at the Earth Institute and an assistant professor at the University of Arizona in the School of Geography, Development, and Environment. She's also a seasoned entrepreneur.
The reason behind me founding Cloud to Street, even before I became a scientist, was based on my role as a disaster relief responder and a community organizer in El Salvador. And I was actually there as a researcher when the communities that I was researching were devastated by landslides and floods. And in that experience of flood recovery and trying to rebuild and build resilience to future floods that was defined by the community, I realized there was a lot that we didn't know. And there were a lot that other nonprofits didn't know about. What do you really need to do to build resilience from flooding? So I went back to grad school to really understand the science of flooding so that I could better inform the types of solutions that people were really wanting to build in places like El Salvador, where they didn't have good access to that type of adaptation information.
In her capacity as both an academic and an entrepreneur, Beth's work has focused closely on understanding the causes and impacts of global environmental change for vulnerable populations. Due to her varied experiences, Beth has developed a very different perspective on how remote sensing scientists can effectively address Sustainable Development Goal number 13. So Goal 13 is take urgent action to combat climate change and its impacts. Why do you think this is a meaningful goal for remote sensing scientists?
Well, what remote sensing scientists do, or a large part of what they do, is understand how the Earth is changing from Earth observing satellites. So to me, that kind of encompasses three parts. We look at and understand how the climate is changing, where and how fast. And those observations are crucial to updating our models of the Earth's climatic system. The second part is mitigation. So understanding all of the different efforts that humans are making to mitigate emissions. And third, adaptation. So there's a lot that we can see about how we as humans both affect the climatic system and also how the climatic system and its changes then affect us through satellite data. So that's a really crucial part, I think, to the larger global goal of understanding and tracking climate change impacts, and the data that we can produce as remote sensing scientists can provide a lot of evidence to help us make better decisions as humanity.
So based on your research, can you talk more about how you respond to some of the things you're seeing in terms of how humans are impacting the system? What happens after you gather the data? How do you help others make better decisions?
So the main kind of part that I track in mapping floods is seeing when they're happening. And We can do that with multiple types of satellites, both in near real time, but we can also do that historically. So we can use the same algorithms to find out where water flows in a certain location and where its surface extent is. We can go back 20 or 30 years using the MODIS or Landsat satellite and see the patterns of flooding over time. So that could help, for example, with land use planning. One example kind of story I can tell that we've worked on with my company at Cloud to Street is working with the World Food Program and the government in the Republic of Congo. About 1 year ago, there were several refugee camps that were set up in the Republic of Congo on the other side of the Congo River, coming in from the Democratic Republic of Congo. And we had been working with the government there to set up a flood mapping near real-time system. And they wanted to know not just where floods were happening in near real time, but are any of these refugee camps at risk? Should any of them be potentially moved? And we were able to look at historic data for 4 different camps and find that there was one camp that had been flooded at least 3 times that we could see in the satellite record. So we recommended that camp be relocated. And on the basis of that evidence, the government was also able to make that recommendation, which they otherwise wouldn't have been able to do. And they were really glad they did, because 1 year following that recommendation, that same community flooded again. So when you think about that one story for relocating a refugee camp in the Republic of Congo, how many other places in the world could maybe use that information if they're able to make relocation decisions? If they had access to that kind of flood history, we could probably protect ourselves from a lot of the impacts of flooding induced by a warming climate.
So for our listeners who aren't super familiar with Goal 13, I want us to provide some context. What are the indicators for Goal 13? How do we know when this goal has been achieved?
This is a really tough one because it's hard to measure when we've taken urgent action to combat climate change and its impacts, because that's so broad. So I think we'll know we've taken urgent action to combat climate change when we have successfully begun to slow the warming of the planet at levels that we think are reasonable for avoiding catastrophic human disaster, which it seems like we were hoping that target would be below 1.5 degrees Celsius of warming. It seems like that's probably no longer feasible, unfortunately. So 2 degrees might have to be the more feasible goal. But I think we will have to have proof that we can peak at 2 degrees Celsius in order to have achieved this goal. Anything beyond that, we will have failed, and we will not have taken urgent action to combat climate change. So there's a lot of kind of buckets you would need to track, but there are things that I think we can think about in terms of global hunger not getting worse, agricultural yields not dropping, and the distribution of food not changing and causing mass famine. We could think about tracking numbers in terms of our losses and recovery from disasters. So there's a lot in that goal. I think that's going to take scientists from so many disciplines to participate, to come up with indicators that can really track honestly how we're progressing or not as a global human society towards that goal.
That's a really good answer. Thank you for tackling such a challenging question. Goal 13 is certainly broad on the SDG website, and I think it's important to have a clear vision for achieving it in all the sectors it involves. Now, as you know, these SDGs are set to be realized by 2030. That's 9 years from now. In your view, how close or far away are we to actually meeting the indicators?
So I'm not a climate scientist or an expert in climate modeling or greenhouse gas emissions, but I think we probably all know that we are not doing great in terms of limiting warming to 1.5 degrees Celsius. And we need way more urgent action than we currently have set up, especially coming from nations like the United States. So not a lot of good news there. However, the couple of bright spots that I will point to I think are related to combating the impacts of climate change. So some things that I've been really excited about working in the flood sector is thinking about different types of disaster risk financing, and specifically insurance and risk transfer. So this, I think before I got into insurance, it seems like this sort of boring, unrelated topic, but now I'm so fascinated by insurance, because what insurance really is how do we provide sort of protection against variants of shock, and how can we pool risk as individuals, as cities, and as countries. So some really interesting programs that I'll point to, I think, are sovereign risk insurance schemes, which is where countries pay into a common fund and then can take money out of that fund when a disaster happens. So I'm excited about all of the innovation that's been happening in that space to adapt to climate change that I think is really promising and can help us enormously. The other thing is that, research shows that adapting to floods works. Countries that have adapted in flood mitigation systems and early warning systems actually does save lives and promotes human development. The question is, who has the resources to invest in that sort of adaptation? And how do we make sure that's more equitable so that some countries aren't getting left behind while other countries are making progress?
Mm-hmm. What's the biggest factor in your view that contributes to the success or failure of our ability to address Goal 13?
Yeah. So the real burden and the real obstacle here in succeeding at keeping emissions below a certain level is with those of us who live in the most developed countries that have been emitting the most. How quickly can we transform our food, energy, and power systems? How quickly can we change socially the ability to make policies that mitigate that? I think it's also related to our ability to collaborate together as a global community, because our ability to finance and respond to climate change will rely on new types of collaboration, like I was talking about with these insurance pools and risk transfer. And we have to change our mentality and think about how we can support each other, and we're interconnected as a global community.
Up next, we dive into Beth's thoughts on a unique way that remote sensing scientists can help support our society's ability to realize SDG 13.
Are you looking to make an impact in geoscience and remote sensing science? Then consider joining one of the Geoscience and Remote Sensing Society's technical committees. From environmental analysis to spaceborne imaging spectroscopy, each technical committee advances innovative research and technology in a specific field of remote sensing. By joining, you'll connect with a community of passionate researchers and professionals who are fostering important international collaborations and steering global research agendas. You'll also gain access to the latest news and state-of-the-art research in the field. Expand your network, enhance your career, and make a difference. Join a GRSS technical committee today by visiting grss-ieee.org/technical committees.
Welcome back. Today, we've been speaking with Dr. Beth Tellman, postdoc at Columbia University, assistant professor at the University of Arizona, and co-founder and chief science officer at Cloud2Street. Through our conversations so far, we've learned that as a society, we are lagging behind on Social Development Goal 13, which is to take urgent action on combating climate change. In Beth's view, there are two key factors that we need to tackle in order to achieve Goal 13. The countries with the highest emissions need to drastically change their food, energy, and power systems to reduce emissions. And globally, we need to collaborate to devise innovative and equitable ways to mitigate and respond to climate disasters as they occur. However, the question still remains: what can remote sensing scientists in particular do to help? Here's what Beth had to say.
I think what decision makers are telling us is what we actually should be focusing on is data fusion and synthesis, and how to measure consistency, which we don't even really have metrics for. For example, in 2018, I led the NASA flood risk mapping workshop with Guy Schumann and Albert Kentner, who are kind of two other flooding remote sensing scientists in my field. And in the survey we ran, we asked people what their largest obstacle was to using satellites for decision making for flooding. And we thought they would say accuracy or spatial resolution. But actually, the number one reason people weren't using Earth observation data, they said, was lack of consistency. And that was so much more important to them than pixel level accuracy of a classification. So I think when we actually ask decision makers what their obstacles are or what they need, we might get a different answer than what we would guess as remote sensing scientists. And it kind of shapes the way that you should be investing in development and innovation as a scientist, both on the long term, what should we be measuring and how, and sort of in the short term, how do I collaborate with designers and engineers to actually produce an actionable product. So it's not just producing some data and making a map or a graph and just thinking that can get included in a decision. There's a lot of institutional analysis and policy analysis you have to do and relationships you have to build to enable the satellite insights you're making as a scientist to be used by real people on the ground. And that's where I get frustrated sometimes when scientists talk about the last mile problem, as in, we've made all of these maps and data. Now we just have to do the last mile of work to get to the decision-making process. But to me, there's two problems with last mile thinking. One is, it's not the last mile. That should be the first mile. The first thing you should do is think about who are the decision makers and what do they need, and start from that point of view. And the second problem with last mile thinking is it's not a mile. It's like 1,000 miles. To be realistic, that what we actually have to do is not just put satellite data onto a web dashboard and make it public and open and think that that's going to make a big change. We have to do all of the other human relationship building, social science, UI, UX design required. And that's 1,000 miles. That's not 1 mile. So it's about understanding what their obstacles are and listening and, in their own words, trying to meet them there.
So I think you're saying that collaboration is key in order for, say, mitigating climate change. So with this kind of collaboration, what are your recommendations for bridging that gap you were talking about between the research scientists are conducting and getting those scientists to meet the needs of those who will use the science?
We need to be building financial support to create and fund space and time for those collaborations to occur. So this is also really a call to action, I think, for funding agencies and foundations. But how do you give long-term funding of like maybe multiple years of involving an entire process of scoping out a problem design, human-centered design, and relationship building that you can do before you even begin the science, and build that into the front end of your project and all of the financing that's needed to do that. And then when you do the science, you actually have checkpoints, again, that you're sort of funded to do along the way so that you actually co-design and build something together. We have to think about how we can work together with granting agencies to come up with new structures to do this in order to enable those types of collaborations. I think that's really critical. And then to get more creative about who is a scientist and who does science and who needs to be in the room. It's not just a scientist and someone in government policy. You also want different types of nonprofits in the room. Companies like the one that I work with can play a really huge sustaining role in developing technology and have a lot of expertise in decision-making tools and user design. And so there's a lot of work that needs to be done to bring a diversity of those voices to the forefront.
So going back to goal 13, is it fair to say that one of the biggest ways we could have a real impact on mitigating climate change is to work with funders and other stakeholders to change the funding of remote sensing science, or the structure of funding, so it focuses more on collaboration and practical use for end users? Or is it a stretch?
No, that's definitely something I think that needs to be done. And the reason that companies can play a role in pushing and doing that is because, by definition, A private sector company has to produce something useful that people will buy. So by design, you are building things that people need and will use, and that's your incentive to grow as an organization. The problem with that is that what happens when the people who are the most impacted by climate change can't pay? So pay for the technology that they need or are under-resourced. So when we think about climate change adaptation, we have to rely on more than just market forces to come up with scaling innovations to adaptation, which is why we really need funding agencies to be a part of that process and to be funding those types of innovations and encouraging similar feedback loops that I think technology startups have done a pretty good job of in the marketplace. So how do we bring that mentality into how we do development generally and think about climate adaptation?
Mm-hmm. Many scientists may see the push for practical research as preventing exploratory science that can eventually lead to more practical solutions. What would you say to these scientists about why practical science is currently essential, particularly in the context of climate change?
So I think what practical science does is gives you a more intimate contact with reality. Nobody knows their landscape better than the people who are living in it. I also think some of the most innovative questions or kind of pushes for me in innovation have not come from my own brain and conversations with other scientists. They've come from end users. And so I think contact with end users actually helps you innovate in a way that you otherwise wouldn't have thought of. So I don't really see trade-offs between basic science and applied research like a lot of other people do. If you're creative and if you're doing it right, I think users will give you the biggest innovations and creativity that you could possibly have in your work. And at the same time, of course, they're also telling you what people actually need to use data and make decisions. So it's really a win-win because it makes your science more innovative and it makes it more responsive to society.
So thinking of the future, what role do you see remote sensing scientists play in helping all of us achieve Goal 13?
So I think what we can do as remote sensing scientists is, of course, continue to do what we do well, develop insights from satellite data about where the Earth is changing, how much, why it's changing, and for whom it's changing. We need to continue to do that science. We need to integrate new sensors. It's the most exciting time I think it ever has been to be a remote sensing scientist. And how do we harness all of that new data and observation to understand how the Earth is changing? I think we also need to do more than science. So how can we get involved with civic organizations to help them use that data to make sure, am I asking the right question as a scientist? Am I building the analytics that people actually need? And am I really listening to what they say? And then we also need to collaborate, not just with other organizations and institutions and end users, but people who aren't traditionally remote sensing scientists. And I think if we can be more collaborative and reach beyond our own remote sensing community, that will naturally create more solutions and institutions that respond to our changing climate. So it's like the best time it's ever been, I think, to be a remote sensing scientist, but also maybe the hardest because you have to do more than make good algorithms to make a difference. And I hope we can do that as a community.
Well, that's all for this episode of Down to Earth. To learn more about Dr. Beth Tellman's work, visit her website at beth-tellman.github.io or connect with her on Twitter at Paz Justicia Vida. Listen to other Down to Earth episodes on Spotify and Apple Podcasts. And give our sponsors a follow at IEEE_GRSS on Twitter and Instagram and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films with help from me, Stephanie Tumampos. Graphics and design by Mylene Briggs of Killam Media. And a special thanks to Fabio Pacifici and Keely Roth for their support. I'm Stephanie Tumampos and you've been listening to Down to Earth.